This is Mr. Beck does your homework, AP Physics Homework 4.3 about torque. This is a two-part question that really could use a good picture. So let's see, the arm of a crane at a construction site is 17 meters long and it makes an angle of 17.8 degrees with the horizontal. So here is my crane. It's got the arm of the construction crane up this way. So whatever is there will be hanging this way. And it makes an angle of 17.8 with the horizontal. So this is 17.8. Assume that the maximum load the crane can handle is limited by the amount of torque the load produces around the base of the arm. What maximum torque can the crane withstand if the maximum load the crane can handle is 688 newtons? So this force right here is 688 newtons. Now, if I want the torque, then that is going to be the radius times the force times the sine of the angle. But this angle is between the radius and the force. I've got a force this way, and I've got a radius that's going to be this arm this way. So what I'm interested in is this angle, not that angle. So my torque is going to be my radius of 17-meter long crane times a force of 688 newtons times the sine of, now my theta is not going to be 17.8, but it's going to be 90 degrees minus 17.8 degrees. And that will give me my maximum torque. Now, question 3 says, what is the maximum load for this crane at an angle of 39.9 degrees with the horizontal? So now I'm going to rearrange my crane. The arm is going to go a little higher, so this is going to be 39.9 degrees. But again, the load is going to be hanging this way, so it's this angle that I want. So now with my crane, I'm going to have a new equation. So now that I know the amount of torque that it can handle, I can set that equal to RF sine theta to figure out the force, because that's going to be the weight of this load, is going to be the force. So I know the amount of torque. My radius is going to be still 17 meters. My force is what I'm looking for, but now the angle that I'm looking for is going to be 90 minus 39.9. So that will give me my force when I solve here and use this torque from the previous problem.